So we're now in the meshing application within ANSYS, and if we look at the mesh that we've managed to create, one of the first things that you can see is that the neighbouring elements between the air and the water actually match up. Their boundaries run straight through the interface between the two mediums. And that's because we unified the two volumes into a single part in the design modeler portion of the setup. Another thing that you can see about the mesh is it's very fine around the hull itself, and then relatively coarse around the outside of the domain. And the main way that we controlled this was that we put a sizing command into effect around the boundary of the hull and the centerboard and rudder. So we specified an element size on the elements that were touching that boundary, and then we specified a growth rate of 1.1 in this case. From the boundary outwards. We put a specific sizing element down the back of the rudder there, which was a little bit smaller in terms of the element size, and a little bit smaller in terms of the growth rate as well, because we were expecting some interesting turbulent effects coming off the back of the rudder there. So that's why we did that. And the mesh that we ended up with was this. And if we look at the number of elements in the mesh, so we look at them there, there's the number of elements. It's about 13,500 elements, which we were happy with. That was within an acceptable range. The other thing that you can notice is all the sections that we named in the design modeler portion of the setup have all been transferred through, so they're labelled here with the letters and the key down the left hand side, so we can be confident that we're taking the data through step by step, and these name selections will end up in Fluent, and we can use them for the setup in Fluent. So if we just move on to the Fluent setup next.